Hey everyone, so today I have Alpha in who solved 1,652 leak code questions. How many is that of the platform? Like
Like close to
literally
half.
almost half, but top 4,000, pretty much that's his exact rank here. Look at the streak, it's an insane streak. He's
Dude, my
done a lot.
streak, I stopped my streak. It's
Oh,
over.
he's dead? That's
It's
crazy. Oh
dead.
yeah, it
I was
died
like, I'm
earlier.
not
Oh,
gonna
the
maintain
seven.
the streak. I think I had like 700.
That's wild. So, wow. So yeah, we have him on for a coding interview. He destroyed the last coding interview. But today I'm going to ask him a very popular Google coding interview. I've asked this to a few candidates. No candidate has been able to solve it. Let's see if this candidate is going to be able to solve it today. So,
All right.
yeah. Holy crap, you did so much LeetCode questions.
Yeah. Got to do more
1,600.
real
I want to
work
I want to get to a
instead of like coding
thousand.
questions.
Then I'm good. But
I would get to 1,000. Let's see.
1,000 days badge. Okay. Let's get straight into it. So, all right, we have an interactive code editor. I want you to get working code. We're prioritizing working code.
All right.
And yeah, here's the question. So
Okay.
we're pretty much going to be given a list of files. It's a very popular Google interview question. All we need to do is print out the list of files into the console, so like this.
All right. So I will say I watched your stream a little yesterday where you gave some hints on this. So that might make it a lot easier for me.
What are you thinking?
Well, you mentioned something like my original idea was when I saw this really quickly yesterday. I mean, I didn't see the person coded or anything. I just like watched for like 5 minutes. But have some nested thing, some nested dictionary thing, and you basically said like a lot of people go with this nested dictionary thing, and
Mm-hmm.
it becomes kind of difficult. So you suggested a tree, and I just thought, okay, well, how would a tree work in my head?
Mm-hmm.
And it actually makes perfect sense. And I will actually say that I mean, it's been a while ago, and it was kind of similar. So I did do a Google text screen. It wasn't exactly this question, but it was very similar.
Mm-hmm.
Something like, you have nested stuff and you have like tabs and whatever. And I was able to do that one, and that was like actually for Google. So,
Mm-hmm.
but yeah, we can
Yeah.
try the tree
So yeah. So
idea.
yeah.
Is
What
what
would be
I'm
your
thinking.
approach?
Yeah. So what I'm thinking, and yeah, I haven't like coded or anything, but oh yeah, let me switch this to actually. Can I switch this to Java as well, just so it'll be a little bit more difficult?
Sure.
All
I
right.
mean, I have a follow up. So if you want to,
Okay. No, it's all. I mean, I'm trying to practice Java, and
okay.
I always do this thing where I'm like, well, if I do it in Python, it'll be easier. But
Yeah.
let's just stick to. You don't learn by doing the easy stuff.
Yeah.
So okay. Okay. How do I? Let's see. Paste it again. Can you paste it again in here?
Sure. Let's put it there.
All right. Yeah, it's fine if you have follow up. So basically, what we want to do is we want to, yeah, I think just knowing like trees better gives me a really good idea of what to do. So essentially, we want to have like a level of where we're at. So for example, this first thing, like we would basically parse all of these, and maybe it wouldn't be super easy, but we'll see. So we want to parse all of this. So like web app would be like level one, and then for this first thing, and then assets would be like level two, and this is like of the tree and so on.
Yeah.
HTML level three, and so you basically want to parse, and you can just split on the what's it called, the the dash or whatever the thing's called, um, to get like an array of strings, and then you parse on that, and then thinking about it, what we want to do is we basically want to uh I think maybe this is kind of like a try almost even. Trying to think of like what this would look like because we want to print these things. Um, hmm. Yeah, actually, even knowing it's a tree, I don't think it's that simple. So Okay. So like for this first example, like we parse all these things. Oh, but then when we print this, can we print in any order? We can,
Yeah,
right?
this is one output and this is another output. I don't really care about the order.
Right. Okay. So now I'm getting it. So basically, what we want to do is like we first want to parse it and put it all into the tree. And so we can have like top level root with just like nothing or whatever. And so it's kind of like a try, I guess. But yeah, we basically have like an n-ary tree, where every level will just have like a the level we're at and like the word we need to print. And then we can kind of just like traverse like once we have that, once we have can I do the drawing here
Mm.
somewhere? Drawing. So we'll have like this top level thing, and then we'll have like other nodes. So this will be like web app, and the web app will have like assets and stuff. So let's just say we have a little bit of stuff. So let's say we have web app. The web app has assets. It also has like index.html and so on and so on and whatever. So we'll make this into a tree structure. We're gonna like put these things in. Yeah. So once we actually do have the tree, I think we can just do a DFS. So essentially, we can just go down. We say like, okay, we're at the web app. The web app is level 1. So let's print web app. And then we just need to have like the number of spaces equivalent to its level. So maybe what for every level we put in like 2 spaces or 3 spaces or whatever. I don't know if you care about that much, or like a tab equivalent to how many what level it's at. So essentially, we'll print web app. Then we'll go down to assets and we'll say like assets is on the lower level, so we'll need like more spaces. So we'll print assets. Then we'll recurse back up to the web app, and then we'll go to index.html, and that's going to be the same level as assets. So we'll print like index.html. So basically, once we have this tree structure, the problem's kind of solved. And then we can just like recursively go down in like a DFS and then do it. So the first step is take all of these and put it into a tree, an array tree, because like every node can have infinite children,
Mm-hmm.
kind of like a try, I guess. And then yeah, and then just traverse down, go down every route, and just print stuff. Does that make sense?
Yep.
Okay. So I guess first thing we need is like to think of like our tree structure, like because it's not going to have like a left and a right, it can have infinite. So we'll have like a tree. And so what do we need to have in this tree? So we basically need to have a level.
Where are you? Okay, there.
Yeah, so we need to have a level. And then we need to have a list of trees or I guess we need one more thing. So we need string like word or whatever. Like what are we actually printing? And then we need to have like a list of tree, which is like children here. And we don't know how many that's going to be. So this is what it looks like, I think. And then now we could insert things in. So we'll have a constructor that will be like public tree. And so what do we need? So we need to give it a level. We need to give it a word. And then we'll just say like this level equals level. This word equals word. And then children will be a array, just like empty. So I think that's fine. Oh, this is string. So we have that, and then we need to be able to like insert a word into here as well. So like public void insert, and then we'll just insert like a word in here. We'll see if we need anything else. And this is basically going to say, okay, tree or new tree equals new tree with level +1 and word. And then we'll say children add new tree. We might need more stuff, but this is essentially kind of what we need for the tree. And then we can just have a traversal. So the first thing is we need to take this thing and create the tree. And so I'm just going to make a root with a level of, let's see, what is your example? So it looks like in your example, this web app thing has like no spaces, right? And then assets has like 1, HTML is 2. Okay. So what we can do in that case is we want to make a topmost directory with just a And can we assume like that we won't have like empty strings and things like that? Like these will all be valid in valid format.
Mm-hmm.
Okay.
Yeah,
So we
they're
can
all
make
gonna have valid format, no trailing spaces, no like starting
okay.
spaces.
So we need to make a root that's just going to be like the topmost thing, and we'll make that like level -1 or something. And then we need to, for all of these, we need to basically insert these into the root. Or we don't need to insert into the root. We need to insert them into like the next thing. So I'll figure out how that's going to go. But yeah, basically, so let's do that. So let's get rid of all of this static. So this will be called like parse files or something, or print files. And it'll be okay. And so it's going to take a, I guess, just like a string array files. Okay. So we want to go through all of our files. And we want to turn it into an array by splitting. So let's see, string array parsed equals, forgot the syntax. I think it's like split, and then you can do this. Hopefully that's correct. Let's see. Split is not applicable. Oh, it's because it's this. So let's just print it just to make sure we're doing it correctly.
Okay.
And then let's go from there. So if we end up printing, what do we get? Oh, we never called it, right? So we have to call print files with this thing. Okay, so we can just copy that in. So just to make sure we're parsing correctly. Oops. All right. String. Okay, so let's see if we're parsing and stuff. Okay, so we have a, oh, I see. So we have this like initial directory that we want to get rid of. Yeah, basically. Or we could parse like this and just ignore the first guy. Either one's fine. Yeah, I guess we could do it. We could say this instead. We could say file and just use a substring. I think should take care of it as well. Okay, so now we have everything. And now basically we need to go through these and insert them in. And ideally, we want to also insert the child. That way we can, so maybe this will return like a tree. So we can do return new tree. So basically we insert it in, and then we keep going. So the other thing actually that I'm thinking for this tree that we need to do is like this child can already be in here is a problem.
Yep.
So yeah, so basically we need to know if it is. So we can have another thing in here, I guess. So basically let's see how we do this. So we can have a map instead, I guess. So we can have a map of string to tree and like this, and then that way this is a,
So is this class a tree node or
it's
a
a
node
tree.
node?
Yeah. I mean, it's a tree node. It's a tree. A tree is a tree node. Basically, it's like the same thing. Yeah.
Okay.
Tree node. Yeah. So, because a tree can be like one node, right? Essentially. So,
Yeah.
okay. So basically, we need to say if
'Cause usually when I
the
see people create like a tree class, usually they have like another node class, and the tree encapsulates nodes. But this tree would
yeah,
just
that
use
makes
node.
sense. Yeah, I think this is just like all together, I guess. So if children contains key word, then we can just return that because we don't want to be inserting if it's already there. Even though that still might be fine, to be honest. Like even like if we put in duplicates, it actually might still work. but this is going to be better. Okay, so basically we do this. We do children add, or it's going to be put word new tree, and then we return the new tree. So we're basically saying we have a map of the string and the tree, and then when we do an insert, this is like, if it's already there, we can just return it. Okay, so now what we want to do is we want to make a root node as well, so we can do that as well. So we can say like tree root equals new tree. Level will make it -1. The word will be nothing, and then the children will be nothing. Okay, so we always want to start at the root whenever we do an insert. And then basically we want to say like, for each one of these, insert it into the root. And then give me back the inserted thing. And if it's already there, it'll just give you back the inserted thing. So I think we should just be able to say in here for string word and parsed. Okay, so we basically just want to say, we want to have like a current thing where we're at, actually. So we could do that here. Tree cur equals root.
Mm-hmm.
So we want to say cur insert word. And this is going to give us back that inserted node. So tree result equals cur insert no word. Yeah. So once we have this, then essentially we get this back. Actually, I think we need to do, or actually, this needs to be cur. So essentially, we insert the word and then we update cur to be that. So now I believe we'll have the full tree. Like this will actually give you the entire thing, assuming our inserts are correct. So now all we have to do is just do a DFS on the root node. Mm-hmm. So we're essentially have to go through all the keys, recurse down to all of them, and then, yeah, basically print them. And I think that will be fine. Let me just double check. So tree equals new. Yeah. Okay. So let's try to do something like that. So we need another one that's like public static void DFS. It's going to take a tree root or node or something. Okay. So what we want to do is we want to print. We basically want to have the number of tabs equal to the level, right? So if node level does not equal -1, because that one we don't want to print, then we want to print here. I don't remember how to tab, like how to print a tab the level times. I mean, I guess we could do a for loop. I don't know if there's like a better way. I think that's probably fine. So we could just say like for int I equals 0, I is less than level.
You do like system print without the ln.
Yeah, I know, but we need it to be sorry, 1 second.
You do like
we need it to be
like this. How many times? Could go like that times.
I don't think you could do it times. I don't think you could do that. So that's why I said you have to do a loop. And then we just do a regular system print. So we'll do like a new line here, I guess. We'll just say like system out print line. We'll just have like a new line here. Okay, so we basically just want to do the normal system print here. Print tab, I guess. It's like this, I think. So this will give us the tabs. Then we want to print the actual node. So then we could do, or actually, I think if we do it this way and we get rid of this. So then we want to print the actual, like, whatever's in this thing, which is node word. And then we want to recurse to all the children, essentially. So the children are just going to be in the values. So for tree val in node children values, we want to call DFS on all those. Okay. And then we just call DFS on the root. And I think that's it. So yeah, I can give this a try and see how we're doing, I guess. feel like this one is like a little bit more complicated to code, less than like, I mean, the algorithm part's also kind of complicated, but yeah, there's like this I always struggle with the string ones. So did we print anything? No.
I don't think you built the, or you ran the DFS. Oh wait, print file.
Yeah, it looks like it just didn't do anything, right? I think. Okay. So maybe let's print the node level. And let's also, because I'm curious, like, what are we even getting? So let's print the node level. Let's print the node word. Okay, because I'm curious if we even recurse to anything. Okay, it looks like we somehow we keep getting -1. Interesting. So it said that everything we put in here was -1 for some reason.
Well, we should build the tree first, then DFS, right? Or
well, I did the insert, so that should build it.
that just built it on one file.
Oh, that's right. Yeah. Sorry. Okay, so I DFS in the wrong place. Yeah, so it needs to be outside. Okay, there we go. So let's see if that fixed it. Okay, so we still don't get anything, which is interesting. So let me just double check. So for string in file, like this file is correct. Root is cur, and then cur equals insert word cur. So let me just double check that these are correct. Okay, so the first one is printed correctly. And then yeah, for string word in parsed, cur equals cur insert word. And then DFS root. So let me just double check this section. So if children contains the word, then we just return it. Otherwise, we make a new tree with this tree's level +1 with the word. Then we put it in the children, and then we return it. Yeah, that part seems correct. It's kind of hard to like print the tree, because I think if I print the tree, it won't give you the right stuff. Let's see. What am I missing? Cur equals root. Yeah, we always want to start at the root. Cur equals cur insert word. And then we DFS root. So if node level... Oh, wait. Oh, no, yeah. If node level does not equal -1. Oh, I see the problem. So we want to not print if it's -1, but we still want to recurse. So what's going on, I think, is like we're just starting at the root, and then we're just never recursing because it's always -1. Okay, so let's see if that fixed it. Okay, well, that's weird. Let me get rid of some of this. Let's also comment out some of this just to see like if it works correctly with one thing or not. Okay, so it says web app. How does it show web app twice? Assets, a HTML. Let me print this as well, just to make sure this is correct. Also, where are we printing the number? It's kind of weird. Okay, so web app assets HTML a.html. Oh yeah, we also want to print like the. We also want to print out. Yeah, I think I screwed this up a little. So we want to print that like double dash thing right in the beginning or something. So. And then here, I think we want to print the word, and then we want to print a new line after. So I guess I can combine that here. I can say print this plus this. Let's see if that makes it any better. Okay, so we have it repeated for some reason.
Well, it might just be you just have too many system prints that some aren't useful. Like
that might be true. Oh yeah, that's right. Okay, yeah, that's right. Yeah. Okay. Okay, there we go. Was that correct for the first one? Web app assets, HTML. Okay, yeah, let's try the whole thing. So yeah, I was like thrown off. Okay, it is because I have too many system prints. Yeah, it's definitely hard to catch your own errors when you're doing it yourself, but when you're like seeing it, it's like, okay, I think this is correct now, right? Or like one of the valid formats.
Nice.
Okay.
Nice. All right, moving on to one more question.
Okay.
Yeah, it's a fun one. What do you think?
Yeah, I think I really struggle on these string ones. Also with this one, like this one really does kind of test if you can just make data structures on the fly. Like even though I knew it was a tree, it was like, how do I have all these things? How do I not have duplicates? So I
Yeah.
don't. I think the algorithmic complexity isn't that bad. But yeah, this was kind of similar to the Google stuff I had, and yeah, they had some. I think it was like they gave you a tree, and then you have to print the nodes based on the level with tabs. So they already gave you a tree. So this one's a little bit harder because like you have to build the tree.
I see.
But yeah.
Yeah. Okay, let me look at the code. Yeah, the code looks clean. Like with the level, I think we don't even really need to track the level. We could just pass that as in like a value in the DFS when we're doing the
Oh,
DFS.
like just pass down +1.
Or like when you're doing the DFS here, like have a level.
Yeah, that would be
That'd
fine.
be
And
fine.
then not, yeah. So I think that would be probably be better. So yeah, you have a level, you don't have the level in the actual tree itself. And then, yeah, that would make sense as well. And then every time you go down, you just do +1. Yeah, that
Yeah.
would work as well. That makes sense. I think that probably would be a bit cleaner as well.
Okay. Yeah. All right. Let's move on to the last question. If we finish early, then I'll just take a quick break before the next guy.
Okay.
Um. So this is I'm gonna post it up here. So this is the next question. We want to just add up two strings, but there's decimal numbers, two decimal numbers.
Mm-hmm. I see. So, okay, so a couple of questions. Can they be negative?
Yeah.
Okay.
Oh
And
no
then
no,
like,
just two positive numbers. Sorry.
okay, and then can they be real like just way outside of, obviously you probably just can't convert to an integer or a
Yeah,
decimal and just add.
you can't
So we
convert to a
say
decimal.
they're like too big or something.
Exactly.
Uh-huh. Okay. So I think in that case, what we need to do, and we said the result needs to be a string, I guess, because it's too big for
Yeah.
an integer.
Exactly.
Right. And we can assume there's always a decimal.
No, it's like the decimal numbers, but some could be dot, some could be decimal, some could not be. Decimals could be huge.
Yeah, so what I'm saying is like, so okay, so we can have
You can have one plus
like
2.5.
right. Can we have things like this? Or can we always assume there's a 0 in the front?
We can get 0.5 too. But let's
Okay.
assume there's zero in the front. Let's assume there's zero in the front.
Okay. So I think
Let's
the first
yeah.
thing to do that I'm thinking is just um yeah, okay. So the thing I'm thinking is like we need to we can do it separately, I want to say, right? So we can like split the number into um, decimal and integer sections and add them. And yeah, I mean that makes sense to me. So essentially we can split the number into integer and decimal sections and add them. For the decimals, we can also kind of normalize, I guess. So for example, if we have like this and we have like this, ideally we want them to be the same length. So I think with a decimal, you can just add zeros to whatever the end is to normalize them, and then you can just do a straightforward addition. And basically, we'll have a result, and we just need to check if we have a carryout at the end. And if we have a carryout, that means that we need to increment our number by 1. And then the numbers, you can just do a normal add as well. So kind of like split them into decimal and integer, add the decimals, add the integers, and then check in the decimal if I have a carryout. And if I do, then I need to, yeah, basically increment my number by 1. If not, just whatever the decimal is.
Increment which number? But okay, we have the decimal, right? If
Yeah,
we have the
so
carryout,
let's say this was like this, right? So we'd have a carry out here at the end, right? We would add, and then we'd have a carry out. We'd have like a 1. And this is the decimal section. So whatever our numbers were, like 123 and whatever, after we do those, we need to add 1 here. I mean, we could do that at the start or add it at the end, but yeah. Essentially, we need to add 1 at the end because our decimal, like, rounded up, essentially, right? That's the only thing I'm thinking of decimals. Like, that's like the edge case, is if when you add the decimal parts, they can round up by 1 value.
Mm-hmm.
Alternatively, maybe we can just do, like, maybe it's even simpler. First, you normalize the numbers, then you just add them together, and then you just put the decimal back where it was. So, for example, in this, I don't know what would be easier to code, but let's say we have 23, 21. So first we normalize the number, so this is 0. So we could say, like, okay, well, this 0, we can just put zeros in front. So this can be like 0, 0, 0, 0. Then the decimal part will be like this, and the decimal part here is like this. So we can just extend the decimal, and then they will always be like the same size.
Mm-hmm.
And then we can just kind of do a normal addition and just remember where the decimal needs to go. So we'll just do a normal addition, basically get rid of all this, and then just put the decimal back where it was at the end. So that would be one way, and then we never have to, like, basically, yeah, we never have to worry about, like, one number being too big or any of that kind of stuff. I don't think we actually have to normalize the numerator. I think we just have to normalize the decimal section. So, like, if this is here, like, this would be fine.
Okay, yeah, I like the first approach because we don't have to find where the decimal needs to go. But
okay, so just split it, add them together, and then add the numbers. I think that makes sense as well. Yeah. Okay, so let's go with that then. Can I code that then?
After we find the result, right, we do 1, 2, 3, and then pretend we had
Yeah.
a carry on. Are we just gonna perform the same addition but with the 1, like same sort of addition but with the 1? Like, take the result of this. So
Oh yeah, actually, yeah. So our initial carry for the number part can just be whatever. Like, if the decimal was a carry, so we'll have a carry number, right? So our carry can just be 1 if the decimal, like, went over, or so 1 if decimal went over, or 0 if not. And then that will basically handle it. So first we do the decimal, figure out if we have a carry, and then we do the number part, and then we just get both of those and we just add those together and then put the decimal between it.
Okay.
And that should be it. Yeah.
All right. Sounds good. For time, we have
so
7 minutes to code it.
We have 7 minutes to code it.
Yeah. Two
Okay,
questions in 20 minutes.
That's gonna be tough. Okay, yeah, we'll see. That goes. All right. Well, let's reuse what we have here. Get rid of this. All right. So, I guess the first part is, like, we can take 2 strings and return. Yeah. So let's do that. So we take 2 strings and we return a number, and we take a carry. So that could be the first part. And I'm seeing if I can use that for both of them. So we take 2 strings, we return a number. Yeah, well, let's just whatever. So this will be like add or string, add string A, string B, and carry. Okay. So basically the result. So I think when we add them, we want to reverse them and then add them and then reverse the result. So let me see how I do a string reverse in Java. I forgot. Reverse. So string builder. Oh yeah, you could do a string builder result to string. Okay, so A equals string builder A reverse to string. Same for B.
You could just define without specifying the data type in Java. Or no?
Well, there's already a data type here.
Oh, okay, I see.
So I think I need to import string builder or something. Or string builder.
Just reusing the same variable from the parameter.
Yeah. Let's see, is undefined for the type solution. Oh, I think I need new.
You can always talk to the AI right there.
Okay, yeah. Yeah, I guess that makes sense. So how do I... Okay, so I want to just reverse these. Okay, there we go. Stringer. Okay, so there's a reverse function. Reverse. Yeah, so new string builder, reverse to string. Isn't that what I did? Yeah, that is. So the annoying thing here, sometimes it takes the compiler a while to get rid of the red, so I wasn't sure if it was right. Okay. So now we need to do the last part, which is like C or as string builder. Okay, so now we need to just go through all the characters. Yeah. 0 I is less than basically, let's see, max A length, B length. Yeah, it's gonna be kind of impossible to do in 7 minutes, or we'll see. Okay, no, so okay, string builder. Okay, so we need to do the what's it called? Int total equals yeah, so we basically need to add them together. So we need to do, I think it's like integer parse int or something. So here, okay, so let's actually first get, I think we can actually get the character and turn it into an integer. So we'll say like a char or a int or something. So if this is beyond what a is, then this is going to be 0. Yeah, so this is like I is greater or equal to a length. If that's the case, then this will be 0. Otherwise, we need to do integer, or I think we can actually do, no, we can do s or a character at I minus that. I think that's fine. Okay, so that's the a character or the a integer. Same for the b. Okay. So basically we get the characters and then we need to like do the add and all that stuff. So int total equals okay, so we need to do the total and the carry. So the total is a int plus b int plus carry, and then we need to divide that by 10. That'll give us like that section. And then we need to do the carry.
Divided by 10.
Yeah. So in Java, that's a floor divide. Actually, do we need to want to do? No. Yeah, you're right. We don't need to do. We want to do mod, right? We want the last digit. So that, and then the carry will be the divide by 10. So carry equals this. This. Okay. Then we need to add the total to the string builder. I think it can take an int. We think we want to convert it to a character, though. I don't know if it does. I guess we'll find out. Not entirely sure. So this might be problematic. Yeah, we'll just do this just in case. Total minus 0, or yeah, just in case. Or actually, yeah, this won't work because it's an integer. Okay, so I think this just works then, because you can just add an integer. Okay, so we do this. Then if we have a carry left over, then we want to add the carry as well. Okay, now we need to just, let's see. We need to just reverse it again and then do a toString again. So return res reverse toString. Okay, hopefully that's right. So this will basically add the two numbers for us. Now we need to do the decimal section. And so the decimal section, the first thing we need to do is we need to normalize the decimal. So if one is longer than the other, I mean, do we need to do that? Maybe we don't. Let's see. Or we could do a reverse as well for the decimal section. Yeah, I think maybe we can just do the same. So let me look at it. So if we have like 0.3433, let's say, and then I have like 0.10. So if I do a reverse as well, so this will be like 3343, and then 10 will be here. So that's not good because I need it to be lined up like this instead. Yeah. So in that case, I think I do need to normalize that. Yeah. So let me look up can I add x zeros to a string in Java at once? Kind of like the thing you were saying. Can I just, like, instead of doing a loop, string builder? Okay, looks like you just have to do a loop. Okay, fine. So string add decimals, string A, string B. Okay, so basically if A length is greater than B length, then we need to get the diff and basically just add zeros to the end of B and then do the reverse. Yeah. Okay. So basically we can say string builder and string builder, or with B, then we need to say for I0, I is less than A length minus B length. Yeah, this can definitely be like cleaned up, but it's fine. So cur add 0. Okay. And then just B equals cur to a string. Okay. Now we need to do the same for the other one. So this is just a copy. And yeah, and you can probably make like helper functions and all that. So if A length is less than B length, then we need to do the opposite. So A, B, A, cur append 0. Okay. Now they're the same length. Now we need to reverse them. So A equals string builder, A reverse to string, and same for B. Okay. All right. Now we need to do, whoops. Now we basically need to do the, I think, or I wonder if we can just call add now, because now our add is the exact same thing, right? So I think instead of doing all this, we can just call the add function, and then we can just check the length. And so basically, so I think the idea here is, like, let's say this was like 8 or whatever. If this gave you a carry, the result would be one thing longer than these, and then we can just check there. So I think we can reuse here. So we can say like int decimal total, and we can reuse the function we already made, which is a b carry will be 0. Or this should be a string. Okay. And so here, we can just check if we have the carry. So int carry equals, so basically decimal total length is greater than
Is
a
there a way
length.
maybe we could just pass in some parameter to add, to maybe like do one where it adds it at the end or doesn't in the other way?
Oh, that's what I'm about to do. Yeah, I'm just calculating the carry, and then I'll just calculate, and then I'll just call carry and get the rest of it. Yeah.
I see.
So basically, yeah. So if this is true, if decimal total length is, then this is 1. Otherwise, it's 0. So I think this add decimals is actually going to be, thinking about it, like we might need to, like, I think this is actually going to be our main function. It won't be like add decimals. It'll be what's it called? Like the whole thing. Or maybe anyway, maybe not. Okay, so I think, yeah, so I think it's something like this. So now I think we can just write our like function that will split it correctly, and then we can clean this up a little bit, and then I think it'll work. So we can do public static string. So this would just be like add decimals or something, or what did I call that? Or add nums. Okay, so now this will be string A, string B. Yeah, this is kind of like definitely could be better. Okay, so the first thing we need to do, I guess maybe let's just focus on the case where they always have a decimal, and then if we have time, we'll do the other stuff. Does that work? Like, we'll just always say they have a decimal, so we don't have to be like, if it doesn't have a decimal, may do this. If it does, we'll just say they always do.
Sure.
Okay, so string num1 or string array num1 equals a split on the dot string array num2 b split on the dot. Okay, so now let's think what we have. So basically decimal 1 equals num1 the second part, decimal 2 equals num1 the second part, or num2 yeah, and then string like maybe not the best I guess we'll do this a or b. Okay, so this will be like a1 b2. Okay, so the numeric part will be string. Okay, so the numeric part will be a10 and the numeric part will be here b2 0. Okay, so we have like all the parts now. We have the numerator for the first one, the denominator for the second one. So now I think we can call, we actually want to take this logic and move it outside. We want to do the normalizing in our main function, and then we just want to call add decimals, and then we can calculate the carry outside as well. Mm-hmm. So basically, we're just going to say, take this over here. Yeah, and we're going to say if decimal 1 is greater than decimal 2, then decimal 2. And then, yeah, and then this is just decimal 2. Okay, and then also the other way, if decimal 2 or 1 is less than decimal 2, then we'll do decimal 1. Okay, so now our decimals are normalized, and now we can calculate the result. In fact, we might not even need this at all. Yeah, because we're just calling our add function essentially now, right? So we're just saying string here, des total equals add des1, des2 with a carry of 0. Okay, so now this will give us, yeah, and I think that should be fine. Let's see why it's not saying. Can't make a static reference, so it needs to be static. Okay, so then we can calculate our carry. And then this is basically just decimal total is the same length as decimal 1. So if it is, then the carry is 0, otherwise it's 1. And now our string num total equals add. So this is like num1, num2 with carry. Okay, and then all we need to do is just we just need to do return num total plus the decimal point plus decimal total. And we can test this with something in here. So we'll say print, what do we call this? Add nums. Okay. And then we can try it out on, I guess, this case. So this will be like string s1, string s2. Okay, s1, s2. Okay, so we can see if it works. There are probably going to be some errors, but let's see what happens. Okay, index out of 1 bounds for length 0, line 55. Okay, so we can print these two things. Let's see, a1 equals a split. Yeah, and then this is a1. Okay, let's print those. A1. And let's print A2 as well, or B2. Yeah, these names are also terrible. So, okay, let's see. Okay, so they're empty for some reason. Interesting. Why is that? We're splitting on the dot. We have a dot. Did I do something really dumb? Like, what am I missing here? Do you see any problems in here?
Let's see.
It seems like something really dumb, but
print on the dot. Okay. Let's make sure we're even getting here.
yeah, I think we are. Yeah. Yeah, so for some reason it's not splitting on the dot.
We ask the AI. Maybe.
Yeah, that's fine. Okay, so if I do this, trying to split string on the dot, but getting empty arrays. Why is that? Okay, let's see. Issue, you're having splitting on the dot because split in Java treats or use a split and really. Oh, it's a regex. I see. Oh, so you need to do. Okay, interesting. Yeah, I did not know that. Oh, I knew it was like some kind of regex thing, but yeah. Okay, so we're getting stuff now.
Yeah.
So did we get the right thing?
Let me just let me.
We did get an answer.
Like 5.5.
Oh yeah, we can try smaller. Yeah, that's a good idea. Okay. We can get rid of all these prints.
11.10.
Oh, it should be 11.0, right?
Yeah.
Okay, so the problem we have is okay, so I see the problem. So the add, whenever we do the add, whenever we have the carry at the end, for the decimal, we shouldn't be adding it. We should be passing it on, right? So basically, like what's going on here is we're doing 5 plus 5. We're getting 0. And then we have a carry, and we're like, it's this line right here.
Yep.
So we basically just need to pass a Boolean flag if this is like a decimal or not. So we can say like decimal. And in this case, we can say it is. And in this case, we can say it's not. And so we only want to do this if it's not a decimal, because the carry should just go to the number. So if carry equals 1, and I mean, you can also like return the carry or something, but yeah, I guess this is like one way. So if it's not decimal, then we want to.
If we don't add the carry, would this work?
Yes.
It's not going to increase the length increase.
Oh, you're right. Oh yeah, you're right. So actually, okay, so yeah, you're right. So what we want to do actually, if the length increases, we would just want to chop it off instead. Yeah, you're right. So basically what we want to do instead is we want to say if so if the decimal total is bigger than the original, then we just want to chop it off. Total length is bigger than our original decimal, then we just want to chop off the front. So des total substring. Okay. There we go. All right. Okay, nice. Yeah, so the last part, I mean, obviously the variable names are pretty bad, and I can clean up to like have all these, if there is no decimal, then put in this thing instead.
Yeah.
But those are like small things. I can do that if you want, if we have time.
No, it's okay. Okay. How do you think you did? Like, how was that?
Yeah, I definitely will say if doing both of these problems, like I feel like this problem by itself should, especially in like Java, or I mean, honestly, whatever, takes a decent amount of time. I mean, maybe there was a way easier way, but I had a decent amount of reusability, and it was still like kind of long.
Yeah.
So I feel like doing this problem, this is probably just going to be like a one problem 35 minutes type of thing. So overall, I think I did okay. Definitely could have, like, this is definitely one that pushes, can you code really fast?
Yeah.
And I coded okay, but I could have coded faster. So that is something I can work on. And in general, I think one of my worst things, because I code in like so many languages, is built-ins and like string kind of stuff, because those are like really language specific.
Yeah. Okay.
So, but overall, I think the algorithm stuff is fine. And yeah, and the first one, yeah, honestly, even though I got that tree hint, I still feel like it's kind of unique. Like LeetCode doesn't really prepare you. I mean, it does a little bit, but it's definitely kind of unique. I think both these were kind of unique. It wasn't just like, oh, I've seen this type of problem, so I had to kind of figure this stuff out on the fly. And I think it was like pretty good, but definitely a lot of places that I can improve in. So
Yeah. No, I
yeah.
think yeah, the first question pretty good. Yeah, you fixed it up with the like yeah, the level thing made sense. But yeah, you could also do the DFS without it. But yeah, no complaints on
Mm-hmm.
the first question. Pretty much the second question you kind of already self-identified of just where you could have went faster was just understanding all of. I think with the string builder you weren't used to the string builder, so it took you extra time to get the string builder like code working. As in
I'm
like
like pretty used to it, but not like advanced. And I
yeah,
definitely feel like if I knew more, I could do it faster. Yeah.
with like these edge cases to reduce the code, one thing you could also do is like just swap them if they're like if the length is here. Like one technique that I always see is just doing something like this. I don't know if this will work here, but let's see. Just swap these.
Oh, if like the first one needs to be bigger, you just like call it again on the reverse or something.
Or like instead of having these two if conditions, right?
Mm-hmm.
We just say if the length of this one is greater than the other,
Mm-hmm.
you just swap the variables. Because I don't think the variables do match.
I see. Yeah, that makes sense. And then the second case will handle the string builder part. Makes sense. You
And then
can't do that in
after,
Java. You have to have a temp, but yeah.
okay, you can't do that.
I see what you're getting at. Yeah. So basically,
Cause
you're saying like if one is bigger than two, then swap, and then it's either two is bigger than one or they're the same, and then your second if statement can handle the zeros.
like you only need one. You don't need to do the two. You don't need to duplicate the code, essentially,
Right.
because you just swap like the smaller one, and then you only have to pad the.
Yeah, I felt like there was like a really big time crunch, so I definitely didn't optimize for like code quality. I was like, I don't have a lot of time. I need to get something working, and there's quite a lot to write.
Yeah,
So yeah,
yeah, no, it makes sense. Yeah,
where if I
cool.
had like time, then I could definitely do it better. Yeah,
Yeah,
cool.
all right. Catch you, man. That was good. That was good. Those were fun questions. I need to. I want to keep looking on Interview.io and find like those good questions like the one I asked you. It
Yeah,
just
I feel
takes
like
time to dig.
this was on Interview IO as well.
This one, I just saw
Yeah.
this randomly. I was looking through some questions I did in the past of in some
Yeah,
of
I
it.
feel like these ones really show language experience a lot more than like leak code, right? So
Yeah, these two aren't on Leak Code, so
yeah. Okay, cool.
cool. All right, see ya, man.
All right. See ya.
Peace. All right, chat. I'm gonna take a quick break. Take a quick break. I'll be right back. It's so good.